In the previous two videos, we did some examples using the elimination method. And in this video, I'm going to tell you about the substitution method. Now, you might wonder, why am I giving you two different methods to solve a system of equations? And the reason is just that sometimes it's easier to use one method rather than the other method. And which method you use really doesn't matter to me. I'm not going to tell you you have to use one method or the other. Again, it's just a matter of which one is going to be easier for a particular problem. So let's look at the substitution method now. In this method, we will first solve one equation for one variable. Does not matter which equation, does not matter which variable. Then we use the expression that we get to substitute into the other equation and solve for the other variable. And then finally, we will back substitute to find the first variable. Now again, this might sound complicated, but I think once you do a few examples, then you realize it's really not so bad. Okay, so let's turn our attention to this example here. We have y is equal to 3x plus 4 and x plus 2y is equal to 29. Why is substitution going to be easier here? Well, because the first step is already taken care of, isn't it? We already have one of the equations solved for one variable. Right? We have y by itself on the left-hand side, and then we have 3x plus 4 on the right-hand side. And so what that means is that I can replace y, the letter y, where I see it in the second equation with this expression 3x plus 4. So let's do that. X plus 2 times 3x plus 4 is equal to 29. Now see, we have an equation with only one variable in it, and we know how to solve that. So let's just go ahead and do that. Distributing the 2, we get 6x plus 8 equals 29. Combine the like terms, we get 7x, and then subtracting 8, we get 21 on the right hand side, and so therefore x is equal to 3. Now once we know x equal to 3, then all we have to do is use that value for x in the first equation to find our value for y. So y is equal to 3 times 3 plus 4. 9 plus 4 is 13. So the solution is x equals 3, y equals 13. Well, let's just check that in the second equation. If x is 3, then we have 3 plus 2 times 13. 2 times 13 is 26. 3 plus 26 is 29. So that gives us a check. Okay, and the solution is outlined here in the notes. Let's do one more example using the substitution method. Okay, now here we have x minus y equals 5, and 0.7x plus 0.2y is equal to 17. Well, it's not quite as easy this time because we don't have one of the equations pre-solved for one of the variables, but it's easy enough to do that in one step simply by adding y to both sides of the first equation, and that will give us x is equal to y plus 5. Well, if x is equal to y plus 5, then we can use that to replace x in the second equation. We get 0.7 times y plus 5 plus 0.2 times y is equal to 17. So distributing the 0.7, we have 0.7 times y plus 3.5 plus 0.2 times y is equal to 17. Subtract 3.5 and combine like terms gives us 0.9 y is equal to what, 14.5? No, 13.5. Okay, and then finally y is equal to 13.5 divided by 0.9. I guess I'll use my calculator here. 13.5 divided by 0.9, and the answer is 15. So y is equal to 15, and now we just go back to the first equation where we see x is equal to y plus 5, so that means x is equal to 20. And the solution is outlined here in the notes.